So hello all, welcome to one shot series, revision series of electricity class 10th physics. Let's start with electricity. So electricity basically the form of energy which comes in our domestic and commercial places, with the help of which all the electricity component work. Basically, electricity consists and constituent from electric charges. We'll start with the charge. So, electric charge basically, we all know the subatomic particle, proton, neutron. They provide charge to a particular substance. The SI unit of charge is coulomb, and whenever we write any SI unit in complete spelling, we always write in the small letter COULOMB, and whenever we write it in symbolic form, we write capital alphabet. It is characterized by excess or a deficiency of electron in the body. Na plus one electron given, that is that it had excess, and so it's given. So there is a magnitude of proton and electron. The magnitude is 1.6 into 10 to the power minus 19 coulomb on both the charges, but in opposite signs. That means in proton it is positive and in electron it is negative. That's why the complete atom is electrically neutral. So if charge on one electron is 1.6 into 10 to the power minus 19 coulomb, using unitary method जो बचपन में सीखा था class 3, इतने में इतना तो एक में कितना. So we'll count number of electrons in 1 coulomb, that would be 1 upon charge, and that would give me 6.25 into 10 to the power 18 electrons, 18 charges. That would constitute 1 coulomb charge. Now there is a quantization of charge. The higher level of quantization you will study in 11th class, but as of now you will be studying Q is equals to NQ. Q, capital Q, is total amount of charges, that's in coulomb, and is number of electrons, a number of charges which we are counting, and Q is charge on one magnitude of one charge, that means 1.6 into 10 to the power minus 19 coulomb. So that is quantization of charges. Now if we talk about the electric charges, there are two types of accumulation, that is static electricity, and the second one is current electricity. So static electricity is basically accumulated on surface. Again, you must have done those practical balloon, dry hair. When you rub it, it sticks to the wall because it accumulates charges on it. Winters, woolen dress you have, and you are rubbing yourself on a plastic chair, your body acquires charge, and when you touch anyone, your body discharges through it and एक छोटा सा spark होता है. So that's accumulated charges, that is static electricity. Talking about the current electricity, current means anything which flow. Water current, air current, you have studied in social science. Current means tendency to flow. So when charges flow, it constitutes current electricity. So talking about the definition of electric current, the rate of flow of electric charges Q, that means total charge, through a specific cross-sectional area of a conductor. If I have a conductor, I am counting on a particular specific cross-section area, the rate of flowing of charges, that means total charge upon total time, will give me rate. Whenever there is rate mentioned, rate is always with respect to time. So current is Q by T. That means the SI unit of current is ampere, the SI unit of coulomb charges is coulomb, and the SI unit of time is second. So ampere is coulombs per second. So that is the SI unit of electric current. Now talking about the direction of current, you have studied what is the current, flow of charges. Now in what direction this flow of charge happens? So basically earlier it was considered that positive terminal of any particular electrical power supply is at higher potential and negative is at lower potential, and the direction is from higher potential to lower potential. So that forms a conventional direction of current. We take conventional direction of current from positive terminal to negative terminal. But later on, with the discovery of electron, proton, and all and other subatomic particles, it is known that not proton travels. The component which travel is electron. So actual direction of current is from negative to positive. But what we take, we always take conventional direction of current. Always conventional direction of current is accountability. That means positive to negative and not negative to positive. But if actual direction of current is asked, that is from negative to positive. Now, talking about the electric potential, potential energy, the inner capability, potential you have studied in 9th class. So the amount of work done moving a particular charge in a particular electric field gives me potential of particular point. So 1 volt is volt is basically SI unit of potential. 1 volt is joules work done per unit charge. So electric potential of a particular point, that means VA would be work done on a particular charge in bringing that charge or in that particular point in a particular electric field. Okay. Now, whenever two different potential or two different points is counted, we take potential difference. So difference between the electric potentials of 2 points within an electric field on a conductor gives me potential difference. So potential difference, again the SI unit is volt only. It's VAB, that means the potential difference between A and B. It's VB minus VA, that means work done at B minus work done at A upon total charge. That means del work done, change in work done per unit charge. This gives me electric potential difference. Now this electric potential difference is the driving force of electric current. Potential difference is basically a sort of, you can count it like this, it is analogous to force जिसकी वजह से कुछ चीज flow कर रही है. तो potential difference है, तो there will be a flow. When there is no potential difference, there will be no flow of charges. So now electric circuit. What is electric circuit? Electric circuit is a closed path in which electric current flows. It comprises of diverse components, wires, switches, power supply, and various components like bulb, like your charger, like anything that constitute an electric circuit. Now, electric circuit, we cannot draw again and again a battery, a cell connected with another cell and a bulb, and all these. We are not in drawing, we are in physics. So for physics, we use circuit diagrams. So circuit diagrams, what are circuit diagrams? They are schematic representation of an electric circuit. So to draw a schematic representation, we use various symbols for various electrical components. Like, see, for electric cell, we use a long dash for the positive terminal and a smaller dash for the negative terminal. For a combination of cells which constitute a battery, we use multiple cells. A plug, that means a switch, a plug-in, plug-out switch is in brackets, closed switch, bracket with a dot. A wire joint, and these are all the electrical components. These are the symbols for various electrical components which we use in general. So you have to learn all these electrical components, especially resistance, wire joint, bulb, rheostat, voltmeter, ammeter, galvanometer, all these. Now, the most important, Ohm's law. What is Ohm's law? As I said, that electric potential difference is the driving force, and because of the driving force, electric current flows. Agar driving force nahi hoga, there won't be any flow of charges. See, suppose these are the two different levels of these are the two different electric potential. If they are at same potential, nothing flows. If I keep one at higher potential, one at lower potential, now because of the difference, there will be flow of something, and that something is charges. So that means potential difference and current are directly proportional to each other, and that gives me a relation between both of them and is known as Ohm's law. So according to this principle, the electric potential, the electric current flowing through a conductor exhibits a direct proportionality to the applied potential difference across its terminal, provided physical factors like temperature remains constant. So, sorry, the spelling of same, SAME. Okay. Now, we say I is directly proportional to V. We can also say V is directly proportional to I. And when the sign of proportionality is removed, we put a constant of proportionality. And here the constant of proportionality is R, which is nothing but resistance. So resistance is V upon I. Now what is the resistance? Resistance is basically a property of a substance by virtue of which it opposes the flow of charges through a conductor. Gati avrodhak, they are the speed breaker. If a vehicle is being driven at a particular speed, to control its speed, various speed drivers are made on the road. Resistance is similar to speed breaker. It opposes the flow of charges. Now, consider this circuit. This is a very important circuit, and you must have seen this circuit in electrical laboratories where you have performed Ohm's law practical in class 10th. A resistance and a potential difference is connected across the resistance, an ammeter is in series with the resistance, and a rheostat is connected to control the amount of current flowing through it. And when we take various values across that particular R of V and I, we plot a graph, and a graph is always an inclined line. Inclined line shows the slope is a perfect line. Not perfect, but it's almost an inclined line and a straight line to a particular extent. वो extent के बाद it loses its resistivity in a directly proportionality. वो आपको नहीं पढ़ना, but to an extent V और I directly proportional होते हैं, and when we plot the graph between them, it will give me a straight line. A straight line, that particular straight line, that slope gives me the resistance of particular circuit. So R is basically V upon I. The SI unit of resistance is ohm. 1 ohm can be defined as 1 volt potential difference, 1 ampere current. So 1 ohm is equal to 1V upon 1A. If 1 volt of potential difference is applied across a conductor such that 1 ampere current flows through it, then the resistance is said to be 1 ohm. And that's how you can make the definition of each and every unit. Now, the dependency of resistance. In the definition of Ohm's law, I have mentioned that physical factors like temperature remains the same. That means temperature affects resistance at some or other point. Now that is dependency of resistance on various factors. So resistance directly proportional to the length of conductor. The longer the conductor, the more is the resistance offered. R is directly proportional to the temperature. Temperature, higher the temperature, more the resistance. You can imagine if the temperature rises, the particle movement rises, hence it's very difficult for the charges to pass through the conductor. As a result, it's directly proportional to the temperature. And R is inversely proportional to the cross-sectional area of the conductor. So combining the first and second dependency, R directly proportional to L, R is inversely proportional to A, it gives me R is directly proportional to L by A. And again, when we remove the proportionality, we have to add a constant, and that constant is rho. Rho is nothing but resistivity, which is the characteristic property of a substance. So rho is resistivity and is a constant of proportionality in this relation. Talking about the resistivity now, it is a characteristic property of a material, measuring its resistance. That means how much electric current will flow through a conductor. Like in metals, it flows more. Like in insulators, it flows very less to no. And that characteristic property is provided by resistivity. Insulators have high resistivity, that means it offers good resistance, and metals have low resistivity, that means it offers less resistance. So talking about the resistivity, good conductors like metals, copper, silver, aluminium, they have the order of 10 to the power minus 8 ohm meter. Now what is ohm meter? Let me tell you one more thing. See, when R is rho L by A. If I send each and everything the other side, it will give me rho is equals to R A upon L. So resistivity basically, when for this formula, this one, when 1 meter square cross section area of a conductor is provided, when 1 meter of length of the conductor is provided, then and when these two things are provided, then resistivity, that means the characteristic property, becomes equal to the resistance offered that particular resistance offered by that particular resistance. So resistivity is numerically equal to resistance when the cross sectional area of a conductor is 1 meter square and when the length of the conductor is 1 meter. So from here we can also define resistivity mathematically. Now second, alloys are generally used in filament of bulbs. So alloy is used as heating element like tungsten, nichrome, and they have the order of 10 to the power minus 6 to 10 to the power minus 4 ohm meter. Now there are semiconductors at particular point they act as an insulator. Again beyond that it will start acting as a conductor, like silicon, germanium, and they have the order 10 to the power minus 2 to 10 to the power 2 ohm meter. That's an approx order. It's not a fixed, but that's an approx order which you can learn. And talking about the good insulators, so good insulators like wood, plastic, glass, they have the higher order of 10 to the power 12 ohm meter to 10 to the power 14 ohm meter. Now we have different devices to measure these parameters which we have studied. The first parameter we have studied is potential difference, electric current, and the devices used to measure these are voltmeter, ammeter, and galvanometer. So voltmeter is basically an electrical instrument which helps in measuring the potential difference, and since difference is at two different points in a circuit, it is connected at two different points. That means if a resistor is here, it is connected parallel to both the resistor. That means it is connected, the voltmeter is connected in parallel. And since it is connected in parallel, again one more branch is provided so that current can flow, and so resistance may deprive of the charges. In order to cope up with that, voltmeter has higher resistance. Its resistance is very high so that no current can pass through it, and it can measure the potential drop between 2 points. Talking about the ammeter, it is an electrical instrument which is capable of measuring the current flowing through a conductor. Again, the complete charges which are entering through it should pass through it so that all the total current can be measured. Hence, the resistance of the ammeter is very low. And there is one more device to measure current, that is galvanometer. But the major advantage of galvanometer is it can measure even the modest current, the smallest current it can measure, and along with the measurement, along with the magnitude, it tells me the direction of the current also. That means the needle of galvanometer is in center. It can measure in this positive direction also, in negative direction also. But in ammeter, the direction matters, positive to positive, negative to negative, and then only it will measure, otherwise the coil will burn out. Now, these resistances which we are studying, the resistances means any electrical appliance, it contains some coils, some components which provide a particular resistance. So the device which provide resistance are resistors. Talking about the resistors, we can combine them, we can connect them in two various schemes. One is series scheme, one is parallel scheme. So talking about the series combination, if I connect resistance such that they are connected end to end, one end is the beginning of the other resistance, then these resistance are said to be connected in series. In series are equivalent. I am not mentioning the complete derivation. There is a derivation also, that the potential drop across. Okay, let me explain that. Suppose this is a resistance R1, R2, R3. This is total A. This is total V which is given to me. This is a battery which I am connecting. This is a key. voltmeter, plus minus, it would be plus, it would be minus, it would be plus, it would be minus, R1, R2, R3. When I plug in the key, the current will start moving in. Let the potential drop at V1 is measured by voltmeter 1. The potential drop at R2 is measured by V2. The potential drop at R3 is measured in V3. Okay. Now we know R is V upon I. So R1 is equals to V1 upon I. R2 is equals to V2 upon I, and R3 is equals to V3 upon I. Now why I am taking I only 1? Because the total current is exiting the battery travels through all the components equally and then enters back. So I is constant. Now from here we get V1 is equals to R1I, V2 is equals to R2I, and V3 is equals to R3I. And if I replace all these three resistance with a single resistance, let that be R equivalent or R total, and that should be equals to V equivalent or V total upon I. That means V equivalent is equals to R equivalent into I. And so this total V is equals to V1 plus V2 plus V3. We can put these values. So R equivalent I is equals to R1I plus R2I plus R3I. Hence we can cut I and we'll get R equivalent is equals to R1 plus R2 plus R3 plus Rn. And that means it is summation of all the resistances. So R equivalent in series is always higher than the single, than every resistance in the particular series. If one resistance stop, suppose this is blown out, then complete circuit is blown out. It becomes open circuit and no current will flow through it. That's why it is not good for connection, and also it is not good for components which require different currents, because the total current traveling exiting the battery travels through all the components. Hence we can say in series combination I is same, that means current in the circuit is same, and V across every resistance is different. Talking about the another scheme, that is parallel scheme. So same in this way we can do a derivation of parallel scheme also. And in parallel scheme, 1 by R equivalent is equals to 1 by R1 plus 1 by R2 plus 1 by R3 and so on up to 1 by Rn. This is when all the resistors are connected in parallel. That means all the resistance start from a point and end at a point. The R equivalent which is obtained is always lower than every single individual resistance in the circuit which are connected in parallel. But the major advantage is every R can operate independently. If R1 is closed, R2 can operate, R3 can operate. If R5 is closed, R6, R7 can operate independently. That means each and every R is connected across the same potential and can draw current as per its requirement. That is a major advantage, and that's why in our domestic circuits, the circuit is connected in parallel. In parallel combination, V, that means potential difference across the resistance are the same, and I is different in various branches, in different branches. Now talking about the heating effect of electric current, the heating effect when when there is an electric circuit which is purely resistance and the source of energy continuously provide this charges, then the energy is dissipated in the form of heat. This dissipation is known as heating effect of electric current. Consider, suppose I current is flowing through a resistor of resistance R, and the potential difference applied is V. The time taken by traveling the charges is T, and the Q amount of charges flows through it. So the total work done, consider total work done to move that charge is W joules, and so the power input to the circuit would be V into Q by T, that means V into I. So the power in a circuit of any particular component is V into I. And heat, which is energy produced in time T, is P into T, that means V into I into T. Now if I apply Ohm's law and if I replace V, I'll get H is equals to I squared T, which is Joules law of heating. This is Joules law, but we can also use H is equals to V square by R T or V into I into T. But for Joules law of heating, you should mention this formula, I square RT. Now talking about the I square RT, if I increase current, if I increase resistance, I can increase the heat produced in particular component. Now how can I increase the resistance of a circuit? You know R is directly proportional to L by A. If I take a long wire, that means I am increasing the length, then resistance increases. Now इतने बड़े resistance, if I am taking a long wire, I cannot accommodate it anywhere. So to accommodate that, coiling structure is used. So resistance, long resistance are coiled, and you must have seen those coiled resistances in filament of bulbs. Now again, R is directly proportional to L upon A. That means inversely proportional to A. If I make the resistance as thin as possible, that means least cross section area, then the heat liberated is more, then the resistance is more, and R offered more, that means H is generated more. So on the basis of this principle, there are some practical applications of heating effects. The practical applications include electric toaster, electric oven, electric kettle, electric heater, electric iron. All these contain heating element. The coil, there is a coil, and when we coil it, it provides a good resistance. When I flows through it in a particular time t, using H equals to I square RT, large amount of heat is generated, and hence these appliances provide heat. Also electric bulb, that bulb contains a filament inside it. To help not getting burned, nitrogen is filled in it so that that filament keeps on glowing and does not get burned. Also there is a safety device which is installed in our homes, that is electric fuse. Electric fuse is made up of an alloy of appropriate heating, yeah, melting point. It is basically a switch type structure. When the amount of current exceeds a particular limit, it melts. As a result, the circuit breaks, hence it prevents the burning of our domestic circuits. Now electric power, the rate of doing work is power. That means electric power is V into I. Vi, that is I square R or V square by R. Okay, as per the given data, as per the scheme of the connection, we'll use this formula. So 1 watt, power 1 watt is equals to 1 volt into 1 ampere. That means 1 VA. Again, you can define 1 watt of power is when 1 volt of potential difference is applied across the conductor and a charge of 1 ampere flows through it. Then the power is said to be 1 watt. Now there are some higher values, that means commercial unit of power, that is 1 kilowatt hour, which is also known as commercial unit. जो हमारे घर में बिजली के बिल आते हैं, जो 100 यूनिट फ्री है, 200 यूनिट फ्री है at various places, those units are basically commercial unit. Those commercial unit is 1 kilowatt hour. 1 kilowatt means 1000 watts and hour means 3600 seconds. That's in standard form, SI unit form, and 1000 into 3600 gives me 3.6 into 10 to the power 6 watt second, and watt second is nothing but joules. So 3.6 into 10 to the power 6 joules of energy is consumed in 1 kilowatt hour. Hence, this is all the theory portion of the electricity chapter. For numerical sections, I'll be providing another lecture, since this was a one-shot series and a quick revision. So I tried to complete the whole chapter within half an hour. I have completed all the concepts which are in this chapter. Go through the concepts. You can pause the video at various points so that you can note down the definitions. You can learn that, and in case of any query, any problem, you can drop comments. I'll try to provide the solution, and I'll try to upload a video as soon as possible which contains all the numerical sections, how to solve the numericals. Till then, revise your concepts, and best of luck for exam.